Welcome back, everybody, for another deep dive. Today, we are going to be diving into the quantum realm to
Okay.
see what quantum mechanics tells us about the nature of reality itself. And our guide for this journey is going to be an excerpt from an article called Quantum Mechanics, Reality, Measurement, and Interpretation. And just heads up, this is going to be a wild ride. So strap in because we're about to explore a world where the observer isn't just a passive bystander, but an active participant in shaping reality itself.
That's right. It really does challenge our everyday intuition about reality.
Yeah, so help me understand this. Are
Yeah.
we actually saying that a particle doesn't have like a definite position or momentum until we measure it?
Well, that is the heart of what's called the observer problem. And it's a central tension in quantum mechanics because
Yeah.
the theory itself only gives us probabilities
Okay.
for outcomes. When we do measure something,
Right.
it's silent on what's happening when we're not looking.
Okay, so it's not just that we don't know the particle's position until we measure it, it's that the act of measuring it somehow forces the particle to choose a position.
Exactly. It's as if reality is kind of like a video game,
Mm.
only rendering in detail what the player's looking at.
Okay.
Everything else is just a sort of blurry potential until it's observed.
Oh, that's a really good analogy. I like that.
Yeah, this idea is something called lazy computation, which is this idea that the universe is super efficient,
Mm.
only calculating details when absolutely necessary.
Like when an observation is made.
Right.
That's incredible. And it raises a lot of questions. But before we go too far down that rabbit hole, I do want to talk about Einstein because he famously, wasn't really a fan of this observer-dependent reality idea.
Yeah, you're right. It challenged his fundamental belief in a deterministic universe, a universe where everything is predetermined,
Right.
like a perfectly tuned clock.
Yep.
And this idea that chance and randomness could play such a fundamental role at the quantum level, it was deeply unsettling to him.
Yeah. I can see how that would be unsettling. So did he think quantum mechanics was just wrong? Or did he think that it was incomplete?
He believed it was incomplete.
Okay.
He saw quantum mechanics as this really powerful tool for prediction, but didn't think it was telling the whole story
Gotcha.
about the nature of reality. He felt there was a deeper level of explanation that we were missing.
It's like watching a movie trailer and trying to guess the whole plot based on those few fleeting scenes.
Right.
You might get some things right, but you're missing a lot of crucial information. So how do we even begin to explore what this deeper level of reality might actually be?
Well, the article dives into the concept of ontology,
Okay.
which is a fancy word for the study of what exists.
Ah,
It grapples with this question. Does quantum mechanics just simply describe the limits of what we can know? Or is it pointing to this really strange, inherent fabric of reality itself?
okay.
And this is where we get into the wave function.
Okay. The wave function, if I remember correctly,
Wow.
it's a mathematical description of a quantum system state, right?
That's right. And it holds all the information you can know about that system. Things like probabilities of finding a particle in certain locations
Yeah.
or with specific energies.
Gotcha.
But here's the thing, and what's intensely debated is whether the wave function itself is just a mathematical tool or if it's a real entity like an electric field.
Okay, I can see how an electric field can be considered real because it has measurable effects in the physical world. It can make my hair stand on end. But how do we even observe or measure a wave function? It just seems like it's more of a theoretical concept.
Right, and that gets to the core of this debate.
Hmm.
Because fields like the electromagnetic field are considered real because they
Mhm.
have these measurable effects. They exist in physical space, they transmit energy,
Yeah.
but the wave function lives in a much more abstract mathematical space.
What do you mean by abstract mathematical space?
Well, think of it this way. You can describe a ball's position in 3D space, right? Length, width, and height. But to capture all the possibilities of a quantum particle, you need a space with many more dimensions to describe a wave function. And it's just not something that we can visualize in the traditional sense.
Oh, okay. So because it exists in this abstract mathematical realm,
Mm.
it's harder to argue that it's real in the same way that we consider an electric field to be real.
Yeah, exactly.
Yeah.
And that's why there's so much discussion about
Yeah.
what the wave function actually represents.
Gotcha.
Is it describing a real physical entity, or is it just this clever mathematical construct that we use to make predictions?
This is where things start to get really interesting for me because the article also talks about these in-between states in quantum mechanics, both in terms of time and space.
Uh-huh.
What do they mean by that? Because it doesn't sound like the universe is this smooth and continuous thing that we think it is in our daily lives.
You're picking up on something really important there because our intuition tells us that, a ball rolling across a table moves in this smooth, continuous path.
Right.
but the wave function might not behave this way.
Yeah.
And this ties into the concept of superposition, which is this idea that a quantum particle can exist in multiple states simultaneously.
Okay, hold on. So until we observe the particle, it's not that it's in one state, but we just don't know which one. It's that it's actually in multiple states at the same time.
Yeah, that's right.
Wow.
That's incredible.
Yeah, it challenges our very notion of what it means for something to exist.
I'm going to need a minute to process that.
Yeah.
So we've got this tension between what we can measure and what actually exists, these wave functions that might be more like blurry clouds of possibilities than definite things. And all these brilliant minds are struggling to bridge the gap between the quantum world and our everyday experiences. Is there anything else in the article that we should highlight before we move on?
Well, there's this one concept, and it's pretty mind-bending.
Okay. Okay, lay it on me.
Yeah.
What's this mind-bending concept?
Okay, so it suggests that we should maybe shift our thinking about wave functions.
Okay.
Instead of seeing them as descriptions of a particle's definite state.
What if we thought of them as like potentialities for different outcomes?
Potentialities. So you're saying that instead of a particle having a fixed position or momentum, it's more like a set of possibilities?
Exactly. It's like the wave function isn't telling us where a particle is, but all the places it could be.
Okay.
And it's the act of observing that collapses this wave function
Gotcha.
of possibilities
Right.
into a single definite outcome.
But if our observations are shaping reality, does that mean we have a special power over the universe?
You know, that's a question that's puzzled physicists and philosophers for ages.
Yeah.
It gets into these profound questions of determinism versus free will
Right.
and the nature of time itself.
Right.
Like, do we actually have any agency in
Well-
shaping reality? Or is everything just preordained?
Whoa, those are some pretty heavy questions. Maybe we should save those for another deep dive.
Yeah.
But staying on the topic of wave functions, the article did mention these cutting-edge computational approaches in physics.
Yeah.
What are those all about?
Well, these approaches use something called Lagrangian submanifolds
Okay.
to try and derive the laws of nature from pure mathematics.
Lagrangian submanifolds. I'm not going to lie, that sounds a bit intimidating. Can you break that down for me?
Well, think of it this way. Physicists are always searching for elegant and comprehensive explanations
Hey.
for how the universe works. They want a unified theory that explains everything,
Right.
from the smallest quantum particles to the largest structures in the cosmos.
Gotcha.
And these computational approaches, while they're still in their early stages, hint at a possible deep connection between classical and quantum mechanics.
So instead of having two sets of rules, one for the quantum world and one for the classical world, there might be a single underlying principle that governs both realms.
That's the idea, and it would be a major breakthrough.
Yeah, it would. But with all these different interpretations and approaches, how do we even begin to make sense of quantum mechanics? It seems like every answer just leads to more questions.
You're right. There are many different interpretations, each with their own strengths and weaknesses.
Yeah.
Like you have the Copenhagen Interpretation, which says we should just focus on the results of our measurements and not worry too much about what's happening when we're not looking.
Isn't that kind of like sweeping the mystery under the rug?
Uh-huh. You could say that,
Right.
but it's a pragmatic approach. And it's been very successful in the practical applications of quantum mechanics.
Okay.
But it doesn't satisfy everyone's curiosity.
Right.
Then you have things like the many worlds interpretation, which suggests that every quantum measurement splits the universe into multiple parallel realities, each representing a different outcome.
Parallel universes. And that sounds like science fiction.
I know, right? But that's what's so captivating about quantum mechanics.
Yeah.
It blurs the lines between science and philosophy,
Yeah.
between what we know and what we can only imagine.
I think what really stands out to me is this idea that reality might not be as fixed and definite
Yeah.
as we think it is. It's like this incredible dance of potentialities, and our observations are what shape the outcome. This entire conversation has been pretty mind-blowing.
It really makes you question your assumptions about the nature of reality.
It does. So as we wrap up our deep dive into the quantum realm, what are some key takeaways you think our listeners should hold on to?
Yeah, it really does make you kind of rethink things.
It does. So as we wrap up our deep dive into the quantum realm, what are some key takeaways you think our listeners should hold on to?
Well, I think the most important thing is to be open-minded,
Okay.
to question our assumptions about the world,
Yeah.
and be open to the possibility that the universe might operate in ways that we don't quite understand.
Right. It reminds me of that quote by Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. Maybe quantum mechanics is giving us a glimpse of the magic of the universe.
I like that. And another key point is that science is this continuous journey of exploration.
Yeah.
We're constantly refining our understanding, pushing the boundaries of knowledge, revising our models of the universe.
It's like we're explorers setting sail into uncharted waters. We may not have all the answers right now, but the thrill of discovery keeps us going. And speaking of uncharted waters, before we conclude this episode, I'd like to leave our listeners with a final thought.
Okay, shoot.
We've talked about this wave function as this collection of potentialities, this menu of possible outcomes. But if the future isn't set in stone until it's observed, does that mean we have an active role in shaping reality? Does our consciousness, our very act of observing, influence the course of events?
That's a profound question, and it's one that I think continues to spark debate and inspire new research.
Yeah.
While we may not have definitive answers yet, the very act of asking these questions, pushes us to a deeper understanding of the universe.
Right, and our place within it really speaks to the power of quantum mechanics to challenge us and reshape our understanding of reality.
Absolutely.
Who knows what incredible insights await us as we continue to explore this quantum realm?
A lot more deep dives, I hope.
Haha. Yes, definitely a lot more deep dives. A huge thank you to all our listeners for joining us on this mind-bending journey. Until next time, keep diving deep.